Hi, and welcome to the Principles of Economics, still Chapter 2. We're going to move in the a little bit more difficult and look at a little bit different model today, and that is the production possibilities frontier. So without further ado, let's go ahead and get into it. This is a little bit longer lecture because we do start this model here in Chapter 2, and then we work with it again in Chapter 3. So let's go ahead and share my screen with you. Okay. Oh, it would help if I put it on the slideshow, so let me do that. Okay, so lots of objectives that we're going to accomplish here, and as I said, some of these you'll see they say student learning objective 3, okay, because we do use this again in chapter 3, and so I'm going to show you what you need to know today and for chapter 2, and then we'll get into it a little bit more in chapter 3. Okay, so a production possibilities frontier is essentially a graph, and that's why I asked you to make sure that you had viewed the math and graphing assessment prior to this. It allows us to talk through it a little bit easier. So really, a production possibilities frontier is a graph of the opportunity cost. Okay, and remember, the opportunity cost is the highest value of the alternative not taken. So we're going to imagine perhaps a simple economy where we have computers that we can produce and we have wheat that we can produce. So what happens is the opportunity cost we know immediately because we have two products. So the opportunity cost of computers is some amount of wheat. The opportunity cost of wheat is some amount of computers. Because we can't produce more of both, then we want to take a look at that in terms of the production possibilities frontier. Okay, but I'm getting a little bit ahead of myself. So what we look at is, first of all, we have a fixed given state of the factors of production. Remember, factors of production are land, labor, and capital. And we're going to hold in the beginning, talking about this, the state of production technology constant. And we'll see what happens if we change that constant, okay? So here we have a simple graph, okay? So remember, if you haven't worked with graphs in a while, that the origin is 0, 0. If I were to extend this graph out, looking like this is coordinate plane 1. Here is 2. Here's 3. And here's 4, okay? I'm going to go ahead and erase that just to remind you where we're at in the coordinate plane system. So we say that the horizontal here is going to be the x-axis, and the vertical is going to be the y. How do you remember that? Because x's have 2 legs, so they kind of walk out, and y's are like Tigger, and they jump up, okay? So again, just gonna kind of keep this pretty clean because I want to explain this easily. Okay, so what we do when we look at a production possibilities frontier and representing the opportunity cost, we're going to say that if we have 2 products, we're going to put one product on the x-axis and the other product on the y-axis. So let me do that. So let's imagine that we have the 2 things you could be doing other than viewing this course right now. So maybe it's sleeping. Today it's a rainy day, so maybe sleeping. And down here, I'm going to put studying because that's what you're doing, okay? So in this case, the opportunity cost of studying is some amount of sleeping. The opportunity cost of sleeping is some amount of studying, but you can't do both at the same time. So what is our factor of production here? Our factor of production is going to be time. It is a constant, and it doesn't matter what you're doing. So for example, 1 minute sleeping means you have 1 less minute to study. Okay? Because time is a constant, we're going to say that maybe you're going to spend an hour and a half either sleeping or studying. So I'm going to start here at 0, and I'm going to say, well, if you'd spend an hour and a half sleeping, put a 90 minutes there, that is one possibility that you could do, okay? The opportunity cost of sleeping in this example is going to be studying, and I'm going to put a mark down here on the x-axis and say 90 minutes of studying. Because you can't do both at the same time, and because the factor of production that we're looking at, I'll put that there, I'm cheating a little bit, and the factor of production that we're looking at, time, is a constant, this production possibilities frontier will be a straight line. Okay, so that brings me to my first really important point, is when is the production possibilities frontier a straight line? It's going to be a straight line if you're only measuring one factor of production. So most of the time in your examples, the factor of production that you'll be measuring and looking at and graphing is going to be labor. Okay, now we could also use land, we could also use capital, but most of the time in your problems it will be labor. The production possibilities frontier will look different if you are measuring more than one factor of production. If we were measuring more than one thing versus time, the production possibilities frontier would be a bowed out shape. So it's going to be bowed out if we are measuring more than one factor of production. Okay, straight line, excuse me, one factor of production, more than one, going to be a bowed out shape. Okay. So again, this just kind of highlights it. If we have one resource, so let's go back to our computers and wheat example. So imagine we have two products. We have computers and we have wheat. And let's say that the problem is looking at labor. So imagine you're a company and you're producing computers or you're producing wheat. You can produce some amount of computers and some amount of wheat. Because I don't have numbers in this exercise, it doesn't matter what I put on which axes. So I'm just going to go ahead and put wheat over here on the y-axis, and I'm going to put computers on the x-axis. Okay, so if I were asked to draw the production possibilities frontier just looking at one and only one factor of production, labor, I'd like to look at the endpoint. So one scenario is I can just produce wheat, and that's going to give me some amount of wheat, and I'll just put 10,000 here. Okay, or I can just produce computers. That's going to give me an endpoint down here, and I'll say 1,000. Because I'm looking at one and only one factor of production, if I connect these two in a straightish line, then this is going to be the production possibilities frontier for wheat and computers. Again, I made up some examples, but this is just giving you the idea. It'll be a straight line if it's measuring one factor of production, then it's going to be a straight line, showing that I can't produce more wheat unless I give up some amount of computers. Okay, or I can just produce wheat, I can just produce computers, or I could also produce anywhere along the line. I could divide it up if you'd like. That leads me to the second thing about a production possibilities frontier, is that the graph, the points mean something. So what we're going to say is if we have a production possibilities here looking at wheat and computers, then if I am inside the triangle, say a point here, 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 any point inside of this shape, oh, darn it, I didn't want to do that. Let me go back. Yeah, here we go. Any point inside of this shape, if I can, there we go. And when I say this shape, I mean any point inside of this area here. Let's try that again. Any point in here. Okay. So if I'm producing at a point inside the production possibilities frontier, and that might be a point again, here, 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 this is bad. And the reason it's bad is because it is inefficient. This means that maybe you have labor standing around doing nothing, and that's inefficient. We don't want that to happen. Anything on the curve, the points I'm adding now, is good because it's efficient. You're producing some amount, or you're studying, or you're sleeping, right? Anything outside of the production possibilities frontier here and here, you can't get to right now. And why can't you get there? Because 90 minutes is all that we're allotted. We're not looking at 2 hours or 4 hours. So let me go to my next one just to make sure that you understand. So again, any point inside the production possibilities frontier is inefficient or bad. On the line is good or efficient. Outside the line in this area over here beyond it is currently unattainable, okay? Because we don't have those resources. We're holding everything constant, so therefore we cannot get to beyond the production possibilities frontier at the current time. Okay, so let's take a look at what this means if we're measuring more than one factor of production. Let's say we have 2 countries and they can produce, or let's just say we have 1 country and you can produce computers or wheat. And now we're measuring land, labor, and capital. Because we're measuring more than one factor of production, in this case we're measuring 3, I'm going to go ahead and put wheat over here. I don't have any numbers, so again, it doesn't matter. I'm going to put wheat on the y-axis, and I'm going to put computers on the x-axis. But now I can produce some amount of wheat or some amount of computers. But instead of a straight line, it is now going to be a bowed out shape. So the question is why? Yes, we're measuring more than one factor of production. So I'm going to write that down first. Then one factor of production. The second reason is that the resources or factors of production that it takes to produce wheat are different than the factors of production to produce computers, right? So maybe you'll need less land for computers, but you need more robotics to produce computers. So you see how we're kind of trading off some of the land, labor, and capital. So that's a really important reason why it would be a bowed out shape. We're measuring more than one factor of production, and the factors of production change as we move our business from producing computers to wheat and wheat to computers. Now, what if I had wheat on the y-axis and let's use something similar. How about wheat's hay, okay, on the x-axis? I'm measuring land, labor, and capital. Okay. Yes, it will be a bowed out shape. But now, when we talk about the similarity of the products, that's different. So computers and wheat would be very bowed, right? But what happens in a production possibilities frontier where the products become similar, it's not going to be a straight line. That's not going to happen. But it might be a very slight bow. So this one's still bowed, but it will flatten out. Still bowed because we're looking at more than one factor of production, but the bow will not be, the curve will not be as dramatic when we start to have two similar products. So hay and wheat are more similar than if I put in another line, and I'll do that just to show you. So maybe computers are here. And so the bow of this would be much more dramatic. Hopefully that makes some sense to you. But again, it flattens out the bow of this. Still not going to be a straight line, but it is going to be flatter. As I said, all aspects of this graph matter. So let's go back to our wheat over here on the Y, and we're going to put computers here on the X. Think about what this might mean, that all aspects matter. So again, I'm measuring more than one factor of production. So I'm going to make this a bowed out shape. This is the amount of computers I could produce. This is the amount of wheat. And why would I say that all facets of this graph matter? Because remember, we could be inside this graph. And inside is inefficient. On the line is efficient. And outside the line is currently unattainable, because we're holding all else constant. Here's another example of production possibilities frontier. This one uses numbers, okay? And we're going to get into that a little bit more next time. But again, remember, this is the y-axis, this is the x, and we have computers and we have cars. So ask yourself, why would this graph be bowed out? And if you said, well, it looks like we're measuring more than one factor of production. So that's correct. Okay. Second reason why it might be bowed out shape, because the factors of production used to produce computers are different than the factors of production used to produce cars. So factors of production of each product is different. Okay. Last thing I want to say is, okay, what are the efficient points on this? So where is this efficient? So hopefully you've been able to easily answer that in your head. The efficient points are F, A, B, and E. Make sure on the test that you do make sure that you give me all the points. Some students forget to do that. What points are inefficient? And I'll do that in a different color just so we can keep track of everything we're talking about here. So where is it inefficient? Point D, right? Because it's inside the curve. We have a corresponding point either here or here, which would become efficient. So D is inefficient. Lastly, what points can't we get to? So what points are unattainable? Given our current state, you guessed it, that's point C. Okay, so when we take a look at this idea, the production possibilities frontier allows us to reap the highest productivity, all right? Here we're making it simple and say getting all we can from scarce resources. And remember, economics is the study of scarce resources. It also shows the trade-offs that we make, okay? So let's take a look at that idea. Okay, again, this is just summing up the inefficient levels of production And now what we want to do is to get a little bit more precise in calculating the opportunity cost. So originally, I said if we have two products, we have computers and we have wheat, that I know that the opportunity cost of computers is wheat and the opportunity cost of wheat are computers. But now I want to be more specific and more precise, and I want to say, if I decide to produce one computer, then how much wheat do I give up? So notice, if you look at that, if you decide to do one and you give up the other, that's the idea of the opportunity cost. So how we calculate the opportunity cost is we just take the slope of the production function. Okay, so, all right, I'm just kind of previewing this a little bit. Okay, so let's take an example, and let's say that in a given economy, we have 50,000 labor hours. Okay, so is this going to be a boat out shape or a straight line? If you answered straight line, you're right. And the reason is because we're measuring one and only one factor of production. To produce one computer, that takes 500 hours. To produce one wheat takes 50 hours. And I would ask you, what's the opportunity cost for one computer in terms of wheat, and what's the opportunity cost for one wheat in terms of computers? In this example, what we're going to do is to actually calculate the opportunity cost. But before we do that, I want to just talk a little bit about the shifting of resources in an economy. So let's hold this off to the side to our next objective, and let's talk about the idea of what happens in a production possibilities frontier. Okay, so let's go back and say we have wheat over here on the y-axis. We have computers over here on the x. Now, we're measuring all three factors of production, so we have a bowed out shape. Now, the bowed out shape also tells us that the opportunity cost changes. When you have a bowed out shape, opportunity cost is no longer constant. I'll put as you produce more of one product, in this case, maybe produce more wheat and less computers. This only happens in a bowed out shape where the opportunity cost changes. It's not a constant rate. So let's look at an example. Here we have computers on the y-axis, and we have cars on the x-axis. And I just want you to look at the two lines. So here, let's read what our prompt is. A technological advance in the computer industry enables the economy to produce more computers for any given amount of cars. So that means that cars aren't going to change here. So we're going to start on the blue line at point A. So we're on the blue line at point A. And then we have a technological advance. This is where we're not holding all these factors constant. That technological advance, meaning perhaps we have better, faster machines that allow us to produce computers. What we're going to see is our trade-off is no longer our opportunity cost changes. And so the technological advance allows us to produce more computers, but the number of cars stays the same. If this were a different exercise and said allowed us to produce more at both points, then we would see the opportunity cost shift on both axes. So first pay attention to which one is it making it easier to produce, and that's going to be the one that shifts. If it says that you're able to produce all, then the entire graph will shift out. Okay, so again, looking at this, it's kind of important. So how about, let's take a look at another example. And again, I'm going to put wheat over here and computers on the X. So we have X and we have Y. So let's say the technological advance enables the economy to produce more computers and cars. Okay, and I'm just going to change up cars to my example and put wheat. What happens here is the production possibilities frontier will actually shift outward on both axes. And we will end up with something that looks like this. So now the attainable points, the points that are on the curve would be out here, because this technological advance has allowed us to produce more of both goods. So in the previous slide, you saw where we could have a technological advance which only allowed us to produce more of one good, or we can have a technological advance which allows us to produce more of both. Okay, next objective, we're going to get into the calculation of the opportunity cost and becoming more precise. At this point, you have learned all of the areas of the production possibilities frontier that matter, what each one means, how to determine if it's a bowed out shape or a straight line, and I'll see you next time for the calculations. So stop the share. So until next time, when we start calculating, and you may want to have a calculator available to you, and we'll see you then. Thanks.